All right, let's look at how to use row operations to find determinants. First up, I want to show you this. With determinants, you can factor a number out of a row and pull it out in front. So like here, we've got 10 times 5, or 10 and 5. You can factor that 5 out and leave a 2 and 1 there. And so this determinant is equal to that determinant. Now, be careful with this because this is a little different than when you're just dealing with matrices instead of the determinant of a matrix. This down here, it's the exact same thing written, but as matrices and not as determinants. And these are not equal because, if you take 5 and you multiply it across this, if you're doing scalar multiplication, you've got to multiply it by every entry in there. So it's just kind of a subtle thing, and it shouldn't be a problem, but I just wanted to point that out because the two things look very much alike. So what our plan is to start out with the matrix A and reduce it to upper triangular form. And we can use row or column operations to do it. So let's do this first example. Now, this is a demonstration of how this method works. It's certainly not the best way to take this determinant. That's a 2 by 2. The best way to take that determinant is to do 9 minus 20. You get 9 minus 20, and you get negative 11. That's the quickest way to do it, and that's actually cofactor expansion, because we're expanding along this top row, and we're doing 3 times the determinant of that matrix, and then we're doing minus 4 times the determinant of that matrix. So that's the quickest way to do this problem. But let's show how this method works. The goal here really is to get a 0 in this position here. So what I want to do is use the 3 up here to 0 out the 5. This is kind of ugly. Tell you what, let's do. Before we do that one, let's do another example. 3, 4, 6, 3. All right, we want to get a 0 here. So in a problem like this, probably what I would do would just be, say, row 2 minus twice row 1. Because when I do that, it'll turn it into 3, 4, then 6 minus 6, then 3 minus 8. 3 minus 8. That's negative 5. That gives me a determinant of negative 15. So on this one, it's pretty easy to do there. This one over here, the original example, it's a little uglier. We want to get a 0 here. So first, let's get a 1 up top. I'm going to factor a 3 out. Let me make this bigger. I'm going to factor a 3 out. That leaves me with 1 and then 4/3. And then I'm going to use the operation row 2 minus 5 row 1. So I get 3, 1, 4/3, and then 5 minus 5 is 0, and here I get 3 minus 5 times 4/3. I could do that, but I'm going to do it on my calculator. 3 minus 5 times 4/3 gives me negative 11/3. So what's that give me? 3 times 1 times negative 11 over 3, which is negative 11. So again, on this example, and on this one over here too, it's kind of silly to use this method because the cofactor expansion is much easier. This one over here, just to double check it, you get 9 minus 24, and sure enough you get negative 15. Let's do a 3 by 3 problem. Find the determinant of this thing using this technique. All right, probably what I would do is get a 1 here by there are a couple things I could do. I could either factor out a 3, or I could interchange rows 1 and 3. Let's factor the 3 out. So I get 3 times 102, 2, negative 3, 4, 1, negative 2, 2. All right, now let's use the 1 to get rid of the other two numbers below it. We'll do row 2 minus twice row 1, and we'll do row 3 minus row 1. So row 1 stays the same. Row 2, we do 2 minus 2, negative 3 minus 0, and then 4 minus 4. Then for the last row, we're going to do 1 minus 1, negative 2 minus 0, and then 2 minus 2. So we get a 0 there. All right. From here, there are a couple of things we could do. One thing I noticed, though, those bottom two rows are almost the same. Let's factor out the 3. And factor out the 2. I'm going to factor out the negatives on both of those. So I get a 3. Got to multiply it by negative 3 and negative 2. That gives me 0, 1, 0, and 0, 1, 0. And remember, if you have two rows that are exactly the same, the determinant of this thing is just 0. So we could stop here and say this is the determinant of this is 0. So overall, we've got 3 times negative 3 times negative 2 times 0. And the determinant of this thing overall is just 0. All right, we got a 4x4, but I'll put that in the next video.